The tank was developed together with Magna Steyr in Graz. Our partners helped us also with the production of this tank. And when we developed this coupling, we worked with a consortium, with a whole group, together with General Motors and Honda also joined this consortium. It's an open consortium, and in addition to the development of this coupling, the standardization efforts have also been undertaken to make sure that this geometry or this design is standardized and becomes a standard which can be used worldwide. The development was done with Walter and Linde, and Walter is the supplier of this coupling. I'm going to show you a short film. That's something you've already seen. It's not new. You have seen for yourselves how you fill the tank of the cars. That's why it's not new. But let's take a look at what happens inside the car.
Nun, Sie haben selbst
You experienced it for yourselves. You connect the coupling, and as soon as the coupling has been connected, the ring is then locked by means of pneumatic force, and the filling process can start. The valves within the car are then opened, and the so-called, as we call it, cold finger is then docked onto the car with a hose. Through this cold finger, as we call it, cryogenic hydrogen will flow. It's a concentric structure for insulation purposes on the one hand, and also to make sure that any return flow of gas, as we fill hydrogen into the tank, gas will flow back, and this gas will actually flow back into the filling station. Now the tank will be filled with liquid hydrogen. So liquid hydrogen goes into the tank, it's sprayed in. And as soon as the 8 kilogram mark is reached, the process is stopped and the so-called cold finger is withdrawn, the valves close again, and you can remove the coupling. Right, the customer then gets into the car, turns the ignition key, and what happens now? He starts the car, and what happens? Gaseous hydrogen is taken out of the tank, flows through the blue lines. This hydrogen is fed to the engine. The red line is where the coolant goes back from the engine to the tank, so that the cryogenic hydrogen is heated locally, so that gas can be produced, because if you don't heat it, it will remain in its liquid state. The gas then is fed to the engine, to the intake duct, or the port, because it's port injection we are talking about here. The mixture is drawn in, it's compressed, and combustion takes place, just like in an ordinary combustion engine. And you might have heard it, you might have heard the difference between the conventional principle and hydrogen. Hydrogen combustion is faster, it's a bit harder, it's a bit more aggressive, and you can also hear the difference. It's a throatier sound. We can switch over to normal mode. Normal mode is direct injection right into the combustion chamber. Hydrogen is drawn in. Conventional fuel is injected directly. Now the exhaust is treated, like I told you before, depending on which range of the characteristic map of the engine is actually operating in. But what is really important is what comes out of the tailpipe, and that's just steam, vapor, H2O.